It doesn't hurt. Okay, so this session we are going to talk about, now we talk about Amanda Little. We talk about the components that if we improve them, the goal is that performance, the computer can do a good job. Yeah, sometimes also we can use some benchmarks to measure. Also, we can use some mean. We have the geometric mean, harmonic mean. We will talk about it. So that's the section here. And again, this is the last session of chapter 2. Hopefully next week, after the test, we go to chapter 3. Today, surely we are not going chapter 3. Well, let's see. If we finish early, we may go. But we'll still talk about chapter 12 also. Okay, so let's look at the objectives. Okay, so okay, so the objective is, the main objective also is here. So the key methods are to find arithmetic mean, harmonic mean, geometric mean, and then the benchmark and SPEC. So that's the main goal of this section. Here we are saying that, I'll say in short, this lecture will cover the different mean calculations used in performance evaluation, as well as what? Benchmarks and specs, or SPEC. That's an acronym. S stands for standard. P stand for, I think, performance. I'm not sure. Yeah, performance, standard performance, and then evaluation. Yeah, standard performance evaluation. The last, of course, is a corporation, corporate. Yeah. So that's our main goal. Understanding these tools, of course, is very essential for at least comparing two computer systems, which one is better or not. I think these are very important. So let's start again. That's our main objective. Go through the benchmark, SPEC, and 3 mean. So first we start with how to calculate the mean. So as we said, we have 3 common formulas used for calculating mean. So here they mention the use of benchmarks to compare system involve calculating the mean also. The mean value of the set of data points related to execution time. Yeah. Okay, so wait for few, if no, now first thing we can say, why do we use the mean then? Why use mean? And why use mean? Or even why we use mean to see how the class perform if they take a test. I'll use the average test to say, oh, the class did good. The average test of the class is 80. Or next time is 100. Or next time is 50. Yeah. The answer is the same to computer too, because workload in this case vary. In the classroom, the test score among the students vary. So we want to find the average approximately. Average will be an average student to make like this, a little bit more, a little bit less. And that's the concept why we are using. So using the mean in a computing system for performance, measure performance of a computer system, is because the workloads vary. If we have the same workload, where the mean then is the same. If 100 students score 50, and I have 100 students in the class, they all score 50, I don't need to calculate the mean. The mean is 50. Yeah, so the variation of the workload. So for example, a single program cannot represent performance. You have to, let's say you run it 10 times. Then some will be high, some will be low, some will be close. Then when you average it to say, yeah, this is good. Yeah. So average will summarize performance across multiple tasks, not one, across multiple tasks. Each task also varies. If it's the same data, then the answer is the same. So I'll say that's the 2 main reasons of using the mean. Workload varies. That's very important. And the mean also will summarize performance across multiple workloads or multiple tasks. Yeah. Benchmarks, we know that word already. Says some framework, standard. This, so I would say benchmark provide a standardized performance test to standardize it. Wait for a few seconds if it's okay. So first we start with arithmetic mean. Yeah. Also one thing, a program with a single task, if it's only single task, man, you can't just measure the time it takes to run one program. Then you decide the computer system run faster or slow. Only one time you run it. Run it like 10 times. You'll see a small differences. Then you average, as we said earlier. So the solution normally will be use a quite of different programs that represent typical workload. Then calculate an average. For example, if I want to measure performance of algorithm, maybe I would try to run the algorithm as many times as I can. If possible, different computer. But even if you put it, it's good to put it in the same computer because if different computer, here we are talking about software. So we don't want the computer architecture is or computer performance like CPU memory. One is higher or lower than the other. Then we are not measuring the performance of the software no more. You see, because if you want to measure performance of a software, we have to run it in the same computer specification. I mean, the hardware, the storage, fastness, it have to be the same for all the computer. So you know how good they're, yeah. So next, as we said, arithmetic mean. In short, I would say that arithmetic mean is one of the simple of no, I should use the word simple. One of the famous or common way of finding mean always from statistics. So that would be just a simple average of all measured values. So to find the mean, we don't have the formula yet, yeah. But basically, you had all the values divided by the number of values. So when to use it, I'll say during the execution times. Execution time, where values are additive. Yeah. Example will be execution time of 3 programs. We have 5 seconds, 10 seconds, 15 seconds. To find the average, we just add all the 3 values, then divide by 3. Yeah. So if I want to find average of 2 values, 6 and 10, it will be 6 times 10 over 2. Why over 2? Because I have 2 values. So the same thing if I have 3, 4 values. 4 values that divide by 4. I will add all 4 values together, divide by 4, and that will give us the average. If it's no question, then that's it. I think I don't want to go through. Let me wait a few seconds. Look what they are rating here. The reason why we all know what this arithmetic means. So, 2 most important thing here. Why do we need it? We explain that. How to do it? We explain that. The rest, I think, mean is one of the common. Arithmetic means one of the common. Oh, okay. So yeah, they even give us the formula. They give us example again. Execution time for 3 program, 5, 10, 15. So the average or the arithmetic mean will be 5 plus 10 plus 50 over 3, which gives us 10. And as we said earlier, it's very useful for additive values. Example, execution time also. Okay, the next is the harmonic. Harmonic, I would say the reciprocal of the arithmetic mean of reciprocals. Wow. Reciprocal of the arithmetic mean of reciprocals is what we call harmonic mean. And is more suitable for rates, like speed up, throughput, and also give more weight to smaller values. Okay, so if no question, I think that's it. Yeah. So again, harmonic mean, as we said earlier, the keyword reciprocal. So the reciprocal of the arithmetic mean of the reciprocals of the data. And we saw the formula, that's the formula on the screen again. from I equal to 1 to n. First of all, n divided by the summation I equal to 1 to n over by 1 over si. So that's why the down formula, you can see we are using 3 over 1, 1, 1. Because n is the number of, in this case, the speed. So that's why here we have 3 and each 1, 1, 1. Okay, so this will take us to geometric mean. Geometric mean will be the nth, here we are using n again, the nth root of the product of n values. Nth root, and that's what we have here. And the product of n values from 1 to n, xi, s if s is n, s times s2, s3, yeah. So we can see example, we have a ratio of 248. So to find the geometric mean, it will be xi, so 2 times 4 times 8 to the power 1n. N here is cube, so 1/3. Because n will be the number. So here we have 1, 2, 3. So n is 3 cube. So 1/3 give us cube. Now if n is 20, then it will be 1 over the exponent will be 1 over 20. 1 over 20. Yeah. Okay, so if no question, let's keep going. The mean are very straightforward concepts. Here we have some comparison of the mean. The only thing I'm very short here, I'll say that arithmetic mean is best for absolute execution times. Then that's what they said. Then harmonic mean, best for throughput when values represent rate. Then geometric mean, best for normalized because of the exponential. Normalized ratios across benchmarks. Okay, so that will take us to the next section. We finish with the 3 means. Next is the benchmark principles. So benchmarks, I would say in short, programs or tests used to evaluate performance because it's a benchmark. So type of benchmarks, we can have synthetic, and also the last one is real world benchmarks. So synthetic benchmark and real world. So if no question, let's keep going. Here also we say it's representative of what particular kind of programming domain or paradigm, such as system programming, numerical programming, commercial programming also. So here we have the system performance evaluation corporation, which is also again a benchmark suit. Here we can also consider the SPECs, the SPEC benchmarks. I would say it's independent organization. It's an independent organization that defines the standard benchmarks. Also, it's an industry accepted method for evaluating system. So that's what we say, an industry consortium defines and maintains the best known collection of benchmark suits aimed at evaluating computer systems. So here we can also say, first of all, why benchmark also is important. Why is it important if we can come up? Benchmark, we want to make sure the same, whatever number or thing we have to do. So I would say it provides unbiased. It doesn't provide bias. It provides unbiased performance reporting. Also ensure reproducibility across different branches and machines, across different machines also. So we have the, as we say, synthetic benchmark and also real world benchmark. Okay. Then we have the SPECs benchmarks also. Now here we can see how the SPECs also work. First step, we need to select. So here we select the benchmark suite. Then we run the test. Here the programs in the suite are run on the system. Any system you want, run on the system you want to test. The execution time for each program again is measured. Each program is measured. Okay, so if no question. So example given expects integer. We have floating point, then we have Java Business Application, JPV. And also it provides an industry standard benchmark. So we have the CPU 2017. We say that's the best known spec benchmark suite. Also, most important, consists of 20 integer benchmarks, 23 40 point benchmarks rating CC++, and also Fortran. So the benchmarks, we have so many application benchmark, even kernel, the operating system kernel benchmark, and synthetic also benchmark. So this example of a SPEC ratio calculation. First, we normalize the execution time against reference machine. Then we find the ratio. So wait for a few seconds. If no question, let's keep going. Okay, so if no question, then let's continue. So this is an example given to us. Then we can see from this example, we have again, first step one, again, this. Okay, so step number one, we need to normalize execution time against reference machine. And the ratio formula is given a reference over the test. See. Then step two, we have to compute geometric mean of ratios. And wait for a few seconds if it's okay. Good. Now, the terms used in spec documentation, again, this are, we have the peak metric, speed metric, etc., etc. Let's wait for a few seconds if it's okay. So a benchmark normally will be a program written again, high-level language that can be compiled and executed on any computer that implement the compiler. Then we have the system under test. This is the system that we want to evaluate. Then we have the reference machine, etc. So again, take a look if any question. Okay, so that will be the conclusion for these lectures. So here again, we focus on arithmetic mean, harmonic mean, geometric mean, the benchmarks, and also the specs or spec. So, so the spec again, we have so many, we saw few. Yeah. We have, for example, spec for crowd and view WPC, etc. Okay, so that will be the end of the lectures. So I'm going to stop the recording if no question.